Welcome back to our lecture series on signals and systems. Continuation of the previous series. Today we are going to learn about the system and its properties and classification. What a system is? As we discussed earlier, a signal is a physical phenomena that can be either represented mathematically or graphically, and it is an information which will be conveyed from one point to another. So for this process to happen, we need a system. A system is a physical entity that operates on the signal or that works on the signal. So this is a physical entity which performs either amplification, filtering or transmission or any other purposes that is required for a fruitful communication or transmission. For example, consider here the block which is represented as H is a system. This may be either a filter or even an amplifier. System properties. What are the major properties of a system? A system can be a stable system or linear system and time variant. Many properties are there. This system has the input as x of t, which gives us output as y of t. The first property of the system which is discussed here is stability. Means a system has to provide a stable output for a stable input. The stability is often referred as bifostable, bounded input and bounded output. As long as the system is stable or as long as the value is less than infinity, the system is considered to be a stable system. So next property is memory or memoryless system. We know what memory is. That is, the system will store the previous values or previous results. Means in the past and previous time periods, whatever the results are obtained, everything is stored. If everything is stored, then it is called as a memory system, which holds the value of past, present values. Whereas memoryless system is the one which does not hold the value of the past. It depends only on the present values. For example, the best example for the past value is the best one is integration. So it accumulates all the signal which has been acquired within a particular time period. So particular time period means the time period may even belong to the past events. So the next is causal and non-causal. Causal system means the output depends upon the present and past values of the input. That is causal. And non-causal system is the one which does not depend on the past and it only purely depends on the present. So all memoryless systems are referred as causal. Why? Because memoryless system also do not depend on the past values. It only depend on the present values, like non-causal. Therefore, all the memoryless systems are defined as or compared with the non-causal system. The next is time invariance, or it is known as LTI, linear time invariance. So this can be verified by changing the time axis at the input and verifying whether the same has been impacted at the output end. So this is called as time variance or time invariant. Even though if there is a change in the input, that change does not affect the output, then it is known as time invariant. Means it does not depend or it does not vary along with the changes what has been done at the input. If suppose the output and input are similar, or the output um, depends on the or changes in accordance with the changes in the input, then it is known as time variance. So next is linearity. Linear system. When a system can be called as linear system, already this linearity principle has been discussed in the properties of signals also. Whenever a system satisfies the property of homogeneity and superposition principle, then that system is named as a linear system. Homogeneity means scaling. Superposition means addition. So these two principles has to be satisfied so as to identify a system or check the system whether it is linear or not. Next is invertibility. Invertibility means reversibility. So any system after undergoing an operation is converted into another system y of t, and it is not sure that if the reversible action has been done on the output, we can get back the input. Like square root of 4 is 2, and again this square will not give the exact answer of like the input. So this is the invertible system. Next is interconnection of systems. Means a system can be connected with each other by two means. One is a cascade, another one is parallel. The other name for cascade is series connection. Means one after the other. If a system has been connected one after the other, the output of one system is given as input to the other system, and similarly the output of the second system is given as the input to the third system. This sequence, this horizontal building of a system is named as a cascade connection, whereas parallel interconnection is nothing but the system that has been connected one below the other, right? Like a piles. So the input is common to both the system 1 and system 2, and the output is taken based on the formula or application. So this is the parallel interconnection, and that one is series interconnection or cascade interconnection. So the last one is feedback interconnection. Feedback, from the name itself we can understand a part of the output is fed back to the input through a system. Again, the feedback is added with the original input and it is fed back to the system. This is a continuous process unless otherwise the expected output is reached. The feedback interconnection system is exactly used for repeated iterations so as to get the expected outcome. So hope you understood this session, students. These are the major points of a system. So the rest we'll see in the next class. Thank you for listening. Thank you.